for the adjoint of P, you're supposed to list down all the elements of P. We have minus 8, minus 14, minus 1, 1, minus 8, minus 14, 1, 2, 2, 1, and 5, 1, 3. So you're going to list these elements again on the right hand side. So we have minus 8, minus 14, 1, 2, 2, 1. You list the elements in this column over here. You list the elements in this column over here. Next, we list the elements in this row over here and the elements on this row over here. So we'll have minus 8, 2, 5, minus 8, 2, minus 14, 2, 1, minus 14, 2. We cross out these elements and we find the determinant of the following matrix. Now, we're going to do it step by step, so I am sure you're going to follow. We find the determinant for each 2 by 2 matrix, this 2 by 2 matrix, and this 2 by 2 matrix. We focus on the first matrix. This will have 2 times 3, which is 6, minus 1 times 1, which is 1. Next matrix, which is this, we have 1 times 5, which is 5, 2 times 3, which is 6. Remember, you are finding the determinant. We have for this matrix, 2 times 1 is 2, minus 5 times 2 is 10. You close your bracket. Then you move to this block. We have 1 times 1, which is 1, minus 3 times 14, which is 42. So plus 42. Next, we have this block. 3 times minus 8 is minus 24, minus 5 times 1, which is minus 5. Next, we have this block. 5 times minus 14 give us minus 70, minus 1 times minus 8 give us plus 8. We have this block. Minus 14 times 1, which is minus 14, minus 1 times 2, which is minus 2. Next is this block. We have 1 times 2, which is 2, minus 8 times 1, which is plus 8. Finally, we have this block. We have minus 8 times 2, which is minus 16, minus 14 times 2, which is plus 28. We add everything in this matrix. We have 5, minus 1, minus 8. We have 43. We have minus 29. We have minus 62. We have minus 16. We have 10. We have 12. So this is the adjoint of P. Next, we find the determinant of P, which is, we have minus 8 to bracket 2 times 3 minus 1. We have minus 2 into bracket 14 times 3, which is minus 42, minus 1 times 1, which is minus 1. we have plus 5 minus 14 minus 2. This gives us minus 8 times 6 minus 1 is 5, then minus 2 into bracket minus 43, then we have plus 5 into bracket minus 16. So we have minus 40 plus 86 minus 80. So we have minus 40 minus 8, we have minus 120 plus 86 minus 34. That's the value for our determinant of P. So P inverse, which is equal to 1 over minus 34 is given by minus 1 over 34 times the adjoint. So all the values we have here, we have 5 minus 1 minus 8, 43 minus 29 minus 62 minus 16, 10, 12. So this is the value for your P inverse. You can check out to see if you have P inverse to be equal to I. So next we have our E of T, which is given by E of the diagonal of the lambdas. So lambda 1, lambda 2, lambda 3, all multiplied by T. Now if you find E of G, this will give you the exponential of the matrix, which I'm not going to look for. You can easily find this one just by taking out the T from this value. So we will just focus on E of T, which is given by E to the power T 0, 0, 0, E to the power 3 T 0, 0, 0, E to the power 4 T. So when you take out the T's, you're going to have E to the power G. So our solution, which is given by X of T, E to the power G T X naught, which is also expressed as P E of T P inverse X naught. So when you write this expression, we'll have our solution. Now in the question, we were told to write a stable, unstable, or center subspace. Now the eigenvalues that we had are all positive. So we will only have unstable subspaces. If we had negative eigenvalues, we would have gotten a stable subspace. Okay, so our unstable subspace is equal to the span of all your eigenvectors, because all of them had positive eigenvalues. So we have the span of your V1, which was given by minus 8, minus 14, and 1. And 2, 2, 1. And finally 5, 1, 3. So these are the unstable subspaces. Next, we are supposed to sketch our face portrait. Next, we will draw our face portrait. So we label our axis as X minus X, Y minus Y, Z and minus Z. So with this, we can now construct our face portrait. The first eigenvector was given as minus 8, minus 14, and 1. The second eigenvector was 2, 2, 1, and the third eigenvector was 5, 1, 3. So we are using the eigenvectors that we had. So we locate minus 8, minus 14 in 1. Next, 2, 2, 1. Now we are looking for the last one, 5, 1, 3. So now we've gotten all our eigenvectors. We are going to list the eigenvalues corresponding to the eigenvectors. So we have lambda 1, we have lambda 2, and lambda 3. Next, we are going to draw a plane on the x and y axis so that we can actually see what is going on. We are going to give our eigenvectors their direction. Since they are unstable, they are all moving out of the origin. Okay, so now what we will do next is to try and give a two-dimensional representation, then we transform it into three-dimensional. We are going to treat lambda 1 as our x-axis, so let me label it x prime, lambda 2 will be y prime, and lambda 3 will be z prime. We are going to treat our x prime, y prime, and z prime as our new coordinate system. So we are going to draw another phase plane for that one with a different color. Our solution will be in this form. If it was two-dimensional, if this was our system with our y-axis here and our x-axis here, lambda 1 to be 1 and lambda 2 to be 3 for the y-axis, our solution will always tend toward the one with the biggest eigenvalue. So our solution will be like this, out from the origin toward infinity, out from the origin toward infinity. So this is the form of our solution, and the other way around we have this. So moving from the origin away, from the origin away, from the origin away. This is what we are supposed to see for a 2 by 2 dimensional system. We are going to see something similar, but this time it's going to move upward because we have 3 eigenvalues and they are all positive, each one being a bigger eigenvalue. So since we've chosen lambda 1 and lambda 2 as our axis, they're going to follow in that direction. So our solution will move upward from the origin. So we have this, we have this and this. The same thing is going to happen on the other side. So we move from the origin this way, from the origin this way, the origin this way, the origin this way. We indicate our direction. As we move up, our solution is going to be bigger. So it will climb on the z prime axis. We will indicate different positions on the z prime line, and you're going to draw our solutions there. So from here we will have this, which is bigger. The next one, but they are all going to be on the green plane. Is that okay? So we'll have this. So we move up, the solution becomes bigger. If you were to draw the next point here, it will be very big, very big, very big, very big, bigger again, big, big, and big. So somewhere here. See that as our solution moves from this point to this point, it becomes bigger. And with each one of them, you're supposed to indicate to show that they are going out from the origin. So as they climb up, they move out of the origin. So that's how our solution is going to be. So we see that when we look at it from this side, in this two-dimensional plane, we see that our first one will be constructed this way, little smaller, smaller. So this is how our solution is going to be like. The first one is a little bit smaller. The next one will also start from the origin, but will become a little bit bigger. Is that okay? Overlapping this one. So this is how our solution is going to be like. And the next one is also going to start from the origin and will also go outward, become bigger. So that's how our solution curve is going to be like. So as it moves up, the more bigger it becomes. So I think this should be enough to give you a rough idea of how the face portrait is going to be like. You're not always going to draw it perfectly, but getting the idea behind it is very beneficial. So I think with this, we will move on to the next section and look at other examples. I'll see you in the next video. If this video has been of help to you, please smash the like button and subscribe to the channel for more content like this. Thank you and see you.